Okay, today I'm gonna talk about the difference of the wave frequency and the sampling frequency, and because sometimes these two can be a little bit confusing. So let's start first with the wave frequency, which is more obvious about what it is, and then we move to the sampling frequency. To start with that, first assume that we have an axis here, the y, and there's a t axis, the time, and then we want to show a wave on that. If we assume that we have a time, and assume this is the 0.5 second and this is 1 second, then if we have a wave that has one crest and one trough, something like that, that goes up, it has one crest and goes down, and then it has one trough and then comes back up. So it has one full cycle or one oscillation or one ups and down. In this case, we will say that the frequency of this wave is 1 Hertz. So there's one ups and down, one full cycle in 1 second. So then it's going to be the frequency is 1 Hertz, means that how many full cycle we have within 1 second. Same here, if we look at another example here, and again it's the 0.5 second, it's going to be 1 second, and we have another wave, which this time instead of having one up and one down cycle, I have two, something like that. So it goes up and comes down, and then goes up and comes down and comes here. So it finished two cycles in 1 second. In that case, we say that it has a frequency of 2 Hertz. In other words, it finished two full cycle in 1 second. If it finished 10 full cycle in 1 second, it's going to be 10 Hertz. So when we are talking about the wave frequency, basically we talk about how many full cycle we have in 1 second of time, and some notation on that, so we know that this is the time that it takes for one full cycle. We call it the period. So here for the above one, so this is the t, because it is the one full cycle goes from 0 to 1, and here the period is going to be this one, because the one full cycle goes from here to here. So this is going to be the t here. So here the t is 1 second, and here for the second one t is 0.5 second, and we know that the t is 1 over f. So if you know that, so if we do that, so it's going to 1 over 2, so it's going to 0.5, or the other way around. And also this is our amplitude here, so we have it the same here. It's the amplitude here. I draw this amplitude smaller than, but it doesn't need to be essentially smaller than it might have very large amplitude like this, so it doesn't, so the amplitude and frequency, they might not be exactly like that. So I just draw them as an example. So it can have an amplitude larger than that, or this one can has a small amplitude like that. For example, let me try to draw one. So for example, this one might have a very small amplitude wave like that, so it has a one full cycle with a very small amplitude, or can have here a very two cycle with a very, for example, big amplitude. So that can be changed, so don't get confused between amplitude and how the frequency works. So basically this is how we are talking about the wave frequency. So when we talk about the wave frequency, we refer to how many full cycles that wave has within 1 second of time. If it has one full cycle, one ups and downs, it's going to be 1 Hertz. Two full cycles, basically two ups and downs is 2 Hertz, and it has 10 ups and downs, it's going to be 10 Hertz, and so on. Now let's look at the sampling frequency. basically when we are talking about a sampling frequency, it means that we have a wave, we have a signal, and we want to measure that signal converted into some data points on a computer or a sensor or something like that. So here again, assume that this is a signal we have. So we have this signal, and assume, for example, here again it's the 0.5 second here, so 1 second, and 1.5. That's gonna be 2 seconds. So we have a one wave that basically, because it's a one ups and down in 1 second, so it has a frequency of 1 hertz. So its frequency is 1 hertz. Now assume we want to measure this wave. But most of the time when we want to measure, we are using some kind of sensors or instrument to measure that, and that those instruments cannot measure continuously. So they measure one data point, they store that data point, and then they measure the next data point, they store that, and so on. And depending on the sensor we have, they most of the time need some time between every two data points that they are going to measure. So it may need 1 second between two data points, it may need 0.5 seconds between two data points, depends on the sensor we are using. Anyway, so assume we have a very good sensor right now, and we can set it to measure at any time interval. Now assume we want to measure this wave. So one way I can go ahead and say that I can set up my instrument and say go ahead and measure every 0.5 seconds and record that. So if I do that, it goes and it records this data point here at 0, 0 for the first point, and it goes 0.5 seconds and pick up this data, and then it goes 0.5 seconds and pick up this data, and then again 0.5 seconds and pick up this data point, and you see, and the same thing here. So it's only pick up the 0. So if I tell my instrument go and pick up, measure this wave every 0.5 seconds, this configuration is only record zeros, so it's not going to be helpful. Now let's see if I go ahead and instead of 0.5 seconds, I set the 0.25 seconds. In other words, it goes here and then here and here and here and here 0.25 seconds. And let's see what happens. So, and I would draw it here. So at the 0, it will record this data point here, and it goes then 2.5 seconds up to here, and it pick up this point, and then I have that point here. Then it goes 2.45 seconds and pick up this point. Then it comes 2.5 seconds here, and it will pick up this point, which is going to be here. And then it will pick up this point, and then 2.5 seconds it will measure this point, 2.5 seconds ahead, this point, 2.5 seconds ahead, this point, and then this point. So if I connect these data together, so these are the discrete data points. So I sample my wave, this is a continuous wave, and I sample it, and the sample wave I have is going to be look like this. So this is how my sampling wave is going to be. Still, the wave frequency I have, and as you can see, the wave frequency is 1 hertz. I have 1 ups and down, 1 ups and down. So the wave frequency is not changing. The wave frequency is 1 hertz. But how I sample this wave? I sample this wave with 4 data points every second. So if I look at the first for 1 second, 1, 2, 3, and 4 data point here, and then this is the start of the second wave. So it's got 1, 2, 3, and 4, and so on. So I sample everyone full cycle. So in other words, in every 1 second, I sample 4 data points. So it's going to be the sampling frequency is going to be 4 hertz. So if you look at the sampling of the frequency of that is 1 hertz, means that 1 ups and downs, 1 ups and downs, 1 full cycle. how many data points I measure within the second, it shows my sampling frequency. So here I use 4 data points in 1 second. Then in the second I only work 4 data points, and this one is going to be actually the start of the third wave, so we don't count that. This is the start of the third wave. So we have 4 data points here, then 4 data points, and basically that's why that in every second we only measure 4 data points, and because of that we will say the sampling frequency 4 Hz, the wave frequency 1 Hz, but we sample 4 data points every second, so we can sample frequency 4 Hz. Now if we go ahead and again double the sampling frequency, I come here and instead of here, and then again we see, so that's the delta t between 2 data points, and it's gonna be 0.25 seconds. And if you compare these two, we would see that sampling frequency is 1 over delta t. So if my delta t is 1.25 seconds, then my sampling frequency is going to be 4. Now what if I go ahead and instead of dividing it into the 2, so here I divide each half a second into 2, so 0.5 seconds, I divide it into the 4. So I divide each of these into 4 and measure at those points. So here I'm gonna, in this case, this is gonna be half of this, so it's gonna be half of so it's gonna be half of 2.5, or other word is a 0.5 divided by 4. So that's the delta t that we have. So this is our delta t. So we divide every half a second into 4 sections. Now if I start to sample that like this, so I go ahead and the first point is here, so again I have this first point, and then the second point that I'm going to sample is this here. So if I bring it down here, it's going to be here, then the next point I'm going to sample is going to be up there, and then this is going to be the next sample point here, and then the next sampling point is going to be here. And this same here, if I keep sampling, so I will have 1 point here, 1 point here, 1 point here, 1 point here. If I again keep sampling and those interval, same I would have these points. So, and then these points, and so I can, if I draw them here, now can see that it's more become like the wave. So it's not still look exactly the best way it can be, but it's become look more like a wave. And so in this case, how many data points have we measured within 1 second? So let's start to, so let me put it here. So this is 0.5, and this is 1 second, it's 1.5, and it's 2 seconds. So within 1 second, if I want to count them again, how many data points I have, so I have 1 data point here, 2, 3, 4, 5, 6, 7, 8, and that's the start of the next wave. So we have 8 data points. We measure 8 data points in 1 second. Therefore, our sampling frequency is gonna be 8 Hz. Means that we measured 8 data points in 1 second. Look at this, the wave frequency. The wave frequency again is not changing because we have 1 ups and downs in 1 second. So the wave frequency is still 1 Hz. It haven't changed. The wave frequency is 1 Hz, but we measured 8 data points in 1 second, and those 8 data points which I inherited them. So it means that we have said the sampling frequency is 8, and we measured 8 data points within 1 second. And it's like that. If we measure 1 second of the wave with 10 data points, then we have 10 Hertz. If we have measured in 1000 data points, then the sampling frequency is 1000 Hertz. And you will see it's completely independent of that wave frequency. One point that I want you to remember that I'm going to mention it here is that if we measure with the sampling frequency of Fs, then we can analyze the wave between 0 to half of that Fs. So if you sample the wave with the sampling frequency of Fs, only we can I forgot Fs, half of Fs. So only we can analyze the wave within the range of 0 to half of that Fs. So in other words, if, for example, if I in my sampling frequency is 8 Hertz, then in my analysis I only can go with the sampling frequency of the 0 and 8 divided by 2, or otherwise in 4 Hertz. I can only analyze the wave within this range. So if in another example, if I want to analyze the data between, for example, 0 and 10 Hertz, then I have to have my sampling frequency 2 times of this maximum value. So my sampling frequency should be at least 20 Hertz in order that I can, in my analysis, I can see the 10 Hertz data. So just remember that whatever frequency range that you have in your mind to analysis, the frequency, the sampling frequency should be 2 times of the maximum value you have within that range you want to study.